Let's crush another Mtel question. This one says a polynomial with real coefficients, p of x, is degree 4 and has roots that include -2 and 3 plus I. Which of the following expressions must be a quadratic factor of p of x? And we've got these answers here. The trick to this question is that if one of our roots is 3 plus I, we must also have the conjugate as a root as well, just by the way that you end up getting I, an imaginary number, as one of your roots. You're always going to have the plus and minus version of I because we're taking a square root that ends up being plus or minus the square root. So just by the rules of roots, if we have 3 plus I as one of our roots, 3 minus I must also be a root, and we can derive our factors from that. So we'll end up getting one factor that's x minus this root, so 3 plus I, and then another factor that's x minus the other root, so it would be x minus 3 minus I. And hopefully if we multiply this out, it'll equal one of these things. So tricky beginning to this problem, very difficult to set up, but this is the case. If you ever have imaginary roots, you're going to have the conjugate of whichever imaginary root you have, and then we're allowed to make the factors where x minus this imaginary number is going to be two separate factors. So now we just want to multiply this out. I'm going to simplify what's in the parentheses a little bit first. So we have x minus 3. I'm just going to distribute this negative through. So x minus 3 minus I times x minus 3 plus I. So now I have to use the distributive property to multiply all these things together. First thing I'm going to do is x times x. I'm going to distribute this x to each one of these things first. So x times x times -3, so we have -3x. Then I have x times I, so plus xi. Then I'm going to multiply the -3 through to each one of these things, so -3x. -3 times -3 is +9. -3 times I is -3i. And then I just want to multiply the -i through to everything. So we're going to end up with -xi. -i times -3 is +3i. -i times +i is -i squared, and I squared is -1 because I is the square root of -1. So I squared equals the square root of -1 squared, which just equals -1. So that's where I'm getting. So -i squared would be -1, which would be +1. Then we're going to have a lot of stuff cancel out here. We've got a +3i. We've got a -3i. We've got a +xi. We've got a -xi. And then everything else can be combined. So the x squared stays the same. We've got -3x and another -3x. So that's -6x. Get a +9 and a +1. That's going to simplify to +10. That's going to give us answer D. So trickiest part to this one, definitely setting it up, but recognizing this pretty obscure rule where if we have one 0 that's 3 plus I, we would also have a 0 that's the conjugate, and then you can set up these factors where it's always going to be x minus your imaginary root for both factors. So we're using both of our imaginary roots, x minus those imaginary roots, and then multiplying it out. Tricky question, but that's the answer.